we have already discussed the Mealy machine in the earlier lecture. So just brush up the formal definition of a Mealy machine. So as I told, here it has the 6 tuples, and Q0, it is a finite set of states. Sigma is used for input symbols. O is used for output symbols. Delta, small delta, it is used for transition function. Transition function, you can say it is it is mapping your current state and input symbol with the next state. And here you can see the output transition function. So here your um, state and the input symbol, it is mapping your output symbol. So this is the difference in the Murray and Mealy machine. And Q0, it indicates the initial state. So now assume that you have to design the Mealy machine for to increment a binary number for 1. So this is the algorithm to solve or to design the Mealy machine. So we have to read the input from right to left. And we will be reading, as it is a binary input, the input string will be a binary, and we will read the binary digits from of the input string from right to left. So from right, you will start reading 1 digit at a time, and you will replace all the ones from right side to 0 till you reach the first 0. You have to replace all the ones from right side with zeros till you reach the first 0. Once you will get the first 0, you replace it by 1. And later, all remaining bits will remain same. So if you want, if you have this number 0, 1, 0, so applying this steps algorithm to this input, so we will start reading from the right side 1 bit at a time. So when you read the first bit itself is the 0. So it means when you come across the first 0, replace it by 1, and rest of the bits will remain same. And that is the reason this 1 get replaced, 0 get replaced to 1, and remaining bits will remain same. Now, if you have another input 1101, so you will be starting with the right hand side. So you will read this one. So as it is mentioned in the algorithm, this rightmost one, it get replaced with 0, as it is a keep on replacing ones by zeros till we reach the first 0. Okay, so this one is replaced by 0. When you, now this is your first one, so replace this first, this is your first 0. So this is your first 0. So replace your first 0 with 1. That is the reason you will get this as 1. And once it is done, first 0 replaced with 1. Remaining bits you have to keep as it is. So that is the reason these last two ones you will find it. So this is the incremental value. And these are, one more example is added here. So you can see the increment of binary number by 1. Now for this, we have to design the Mealy machine. So it is, your execution will start from the way some state, let's say Q0. And if your Q0 is getting 1 as an input, so you just have to go on replace that 1 with 0. Or you will, when your state Q0 will receive 1 as a input, it will produce output 0. And when it will receive 0, first 0, that time also it will replace that 0 by 1. And then after that, if it receives any other bit, you have to keep it as it is. So if same thing, you could see here. So when your Q0 state, when it will receive 1 n number of ones, it will generate the output 0. And when it will receive 0 as a input, it will generate output as a 1. And then because this is your first one, all ones you replace with 0, because when it will go on reading 1, it will start producing output 0. And when and this process, it will continue from the right hand side. So all ones get replaced with 0, and if you come across the first 0, this q0 will replace, or once when q0 will read the first 0, it will produce output 1, and then it will move to another state where it will, for whatever input 0 or 1, it will produce the same output. And that is result is recursive. On getting q1 on getting 0 input, it is producing 0 output. q1 on getting 1 input, it is producing 1 output. And from this transition graph, you can see here it is a STF, state transition function, and you can see here it is a machine function. So take a note of this. Now here we have to design a Mealy machine to find the two's complement. So as per the algorithm, uh, first step is read beat by beat from LSB, right? That is from right to left. You have to read the input beat by beat. Okay, fine. Then what is the another step? Keep the beats unchanged till you reach the first one. It means till first one, unless and until you are not getting the first one, you have to keep beat unchanged. It means because it is a binary input, so definitely you will be having only two digits, two types of digits. Either you will be having one or you will be having a zero. So it means you are not getting the first one. It means what? You are getting zeros only. So in other words, I can say you have to, if you are reading zeros, then you have to keep zeros as it is. And when you will come across the first one, you have to keep that first one unchanged. So if we have to draw the Mealy machine, then you're assume that this is your first initial state, and this initial state will receive digits either 0 or 1. So if it will receive 0, we have to keep it uh, unchanged, right? According to this, keep the bits unchanged till you reach the first one. If you are not getting the first one, if you are not getting the one, it means you are getting zeros. So if you are getting zeros, you should keep it unchanged. So keeping that thing in mind, we have to draw the self loop. So when your initial state q0 will receive the 0, it will keep it as it is. So it means on receiving input 0, the output will be also 0. Okay. So assume that from the, this is your input. If this is your input. So for first three zeros, it will produce output as a 0, right? Now when it will come across this fourth digit, which is 1, so what they are saying, uh, do not replace the first one by 0. So first one you should not replace by 0. So we have to keep it intact. Okay, fine. And then for remaining, we have another action to do. So to perform that another action, we will need to move to another state. So I'll just draw that another state so that it will be easy to show other transitions. So for q0, when it will receive 0, it will make it, it will keep it as it is. When it will receive first one, that one also it has to keep intact. And that is the reason on receiving input 1, the output produced by the Mealy machine will also be 1. Okay. Once after that, once you will keep all your zeros as it is, first one as it is, then remaining bits you have to change. You have to replace 0 with 1 and 1 with 0. Okay. So so 0, you have to replace it with 1. So when it will read 0, it will produce output 1. And when it will read 1, it will produce output 0. This is your initial state Q0. Second state Q1. So this is how your Mealy machine to complete those complement will be constructed. And depending on this, depending on this transition graph, then you can design your state transition function and machine function. So the designing of state transition function and machine function, uh, I'll keep it as homework for you, or you can do it now. I can give you some more time, 5 minutes time I'll give. You just draw your machine function and transition function, and then we can cross check it. Yes, so for this transition function, transition graph, draw the machine function and the state function.